Hello viewer, this is Krishna sir. In this video, I am going to solve the third bit of first problem of exercise 2.2 from the NCERT textbook. So let us see the third bit of the first problem. So in the third bit of first problem, we have been given a quadratic polynomial 6x square minus 3 minus 7x. We need to find the zeros of this quadratic polynomial and then we need to verify the relationship between the zeros of the polynomial and the quotients of the given polynomial. So let us do it. So the quadratic polynomial which is given here, it is not in a proper order. So I will write the given polynomial in the decreasing order of the powers of the variable. So this same quadratic polynomial, I will write it as 6x square minus 7x minus 3. Now what I will do is, I will compare the given quadratic polynomial with the standard form of the quadratic polynomial. We know that the standard form of the quadratic polynomial is ax square plus bx plus c. So if I compare the given quadratic polynomial with the standard form of the quadratic polynomial, I will get the value of a is equal to 6, value of b will be equal to minus 7 and the value of c will be equal to minus 3. Now I will find the value of a into c. So a into c is equal to 6 into minus 3. So this is equal to minus 18. Now I will select two factors of minus 18 in such a way that when I add up those two factors, I should get the value of b, that is equal to minus 7. So this minus 18 I will write it as equal to minus 9 into 2. So minus 9 into 2 is minus 18. So if I add minus 9 and 2, so if I add minus 9 and 2, I will get minus 9 plus 2 is nothing but equal to minus 7. This minus 7 is nothing but the value of b. 6x square minus 7x minus 3. This is the given quadratic polynomial. I can write this given quadratic polynomial as this is equal to 6x square plus 2x minus 9x minus 3. So see here, plus 2x minus 9x is nothing but minus 7x. So this can be written as equal to, if I take 2x common, I will be left with 3x plus 1. So see here, 2x into 3x is nothing but 6x square, 2x into 1 is nothing but plus 2x. In the same way, I will take minus 3 common, so I will get 3x plus 1. So minus 3 into 3x is minus 9x, minus 3 into plus 1 is minus 3. So if you observe here, I am getting 3x plus 1 common in both the places. So I can take 3x plus 1 as the common. If I take 3x plus 1 as common, then I will be left with 2x minus 3. If the given quadratic polynomial 6x square minus 7x minus 3, if it is equal to 0, then 3x plus 1 into 2x minus 3, this should be equal to 0. So if the given quadratic polynomial, if it is equal to 0, then 3x plus 1 into 2x minus 3 should be equal to 0. So if 3x plus 1 into 2x minus 3, if it is equal to 0, then either 3x plus 1 is equal to 0 or 2x minus 3 is equal to 0. So if 3x plus 1 is equal to 0, then, so see here, on the left hand side of the equal to sign, I have plus 1. If I take this to the other side of the equal to sign, it will become minus 1. Then 3x will be equal to minus 1. Now see here, 3 is multiplying x. If I take this 3 to other side of the equal to sign, it will divide. Or x is equal to minus 1 by 3. So we got 1 0 of the polynomial. In the same way, we have to find the other 0 of the polynomial. If 2x minus 3 is equal to 0, then So on the left side of the equal to sign, I have minus 3. If I take this minus 3 to the other side of the equal to sign, it will become plus 3. Then 2x is equal to plus 3. So here on the left side of the equal to sign, I have 2x. 2 is multiplying x here. If I take this 2 to the other side of the equal to sign, it will divide. Or x is equal to 3 by 2. Therefore, the zeros of the polynomial are nothing but equal to minus 1 by 3, comma 3 by 2. So we got the two zeros of the given polynomial. So we solve the first part of the answer. Now we need to verify the relationship between the zeros of the given polynomial and the quotients of the given polynomial. So let us find sum of zeros. Sum of zeros is equal to, what are the two zeros of the polynomial? Minus 1 by 3 plus 3 by 2. So if I take LCM, I'll get minus 1 into 2, minus 1 into 2 plus 3 into 3, 3 into 3 by 3 into 2, denominator 3 into 2, 3 into 2. So this is equal to minus 1 into 2 is minus 2, 3 into 3 is plus 9 by 6. So this is equal to 7 by 6. Now this 7 I will write it as equal to minus of minus 7 by 6. So minus into minus is plus. So plus 7 I wrote it as minus into minus 7. So what is minus 7? Minus 7 is nothing but the value of b. So this I can write it as equal to minus b by, what is 6? 6 is nothing but the value of a. So minus b by a. So I am getting the sum of zeros is equal to minus b by a. In the same way, product of zeros. Product of zeros is equal to, what is product of zeros? Minus 1 by 3 into 3 by 2. So 3 will get cancelled. This is equal to minus 1 by 2. So this minus 1 by 2 I will write it as minus 3 by 6. So minus 1 by 2 I am writing it as minus 3 by 6. Minus 3 by 6 is nothing but equal to minus 1 by 2. So this is equal to, what is minus 3? Minus 3 is nothing but equal to c. C by, what is 6? 6 is nothing but value of a. So a is 6. So this is equal to c by a. So I am getting the product of zeros is equal to c by a. So the sum of the zeros I am getting it as minus b by a, and the product of zeros I am getting it as equal to c by a. So this verifies the relationship between the quotients of the given quadratic polynomial and the zeros of the given quadratic polynomial. So this is how these kind of problems should be solved.